Today we want to look at adding and subtracting integers. To do this, we're going to use a type of flow map. So first we're going to kind of jot down what the flow map looks like, and then we're going to use it on several different problems. First we're going to look at when we're adding integers. Now when we're adding integers, that means the operation itself is addition. And we want to look at the signs that are associated with it. So either the two things that we're trying to add have the same signs, or they have different signs. When I'm talking about signs, I'm talking about whether it's a positive or whether it's a negative number. If they have the same signs, what we're going to do is add the numbers together and keep the sign. So if I was adding two positive numbers, I'd end up with a positive answer. If I was adding two negative numbers, I would end up with a negative answer. If I have different signs, I'm going to subtract the numbers and keep the sign of the larger absolute value. So, that's for addition. If by chance we have something that's for subtraction, we'll go ahead and put over here for subtracting integers. If we were doing subtraction, what we want to do is just memorize this first set and then change everything from subtraction to addition. That way we just have to have this one set memorized. We just know how to change it so that we can work with it. So if it's subtracting integers, we're going to leave the first term alone. Then we're going to change from subtraction to addition. So we're actually changing the operation symbol there. And then we're going to use the opposite of the second term. After we leave the first term alone, change from subtraction to addition, and then use the opposite of the second term, then our problem should be set up so that we can just follow our addition rules. Alright, well, let's see how that works. Let's look at some problems. First problem, 2 plus 4. First we look at our operation symbol. Is this addition or is it subtraction? It's addition, so we're going to follow the rules over here. I'm adding a positive 2 and a positive 4. They have the same signs, so I'm going to add the numbers and keep the sign. So 2 plus 4 would give me 6. They're both positive, so it should be a positive 6. If I was doing 6 plus 2, I have addition, so I'm going to be adding the integers. Both of them are positive numbers, a positive 6 and a positive 2, so they have the same signs. So I'm going to add the numbers. 6 plus 2 would be 8. and I'm going to keep the sign. They were both positive, so it's going to be a positive 8. If I had another example, have 4 plus negative 3. Notice on this one the operation is addition, so we're adding integers, but they have different signs. This is a positive 4, this is a negative 3. Since they have different signs, we're going to subtract the numbers, so 4 minus 3 would be 1. And we're going to keep the sign of the larger absolute value. So if I took the absolute value of 4, that means it's 4 away. If I took the absolute value of negative 3, that means it's 3 away from 0. Which one's larger, 4 or 3? The 4. Since it has a positive sign, we would end up with a positive 1. We'll look at another one of those. We have 9 plus negative 6. Typically those would be in parentheses if they follow an operation symbol so that you can see the negative goes with the number. So on this one we have 9 plus negative 6. So it is an addition problem. If I'm looking at the signs, this is a positive 9, this is a negative 6. So they have different signs. That means we're going to subtract the numbers. 9 minus 6 would give 3. And we're going to keep the sign of the larger absolute value. So the absolute value of 9 would be 9. Absolute value of negative 6 would be 6. So this one would be larger. So we'd keep the positive sign. So that would give us a positive 3. Let's do another example. Negative 5 plus 2. This is an addition problem because it has an addition sign. We have a negative 5 and a positive 2, so those are different signs. We want to subtract the numbers and keep the sign of the larger absolute value. So 5 minus 2 would give us 3. Absolute value of negative 5 would be 5. Absolute value of 2 would be 2. This one's the larger one, so we're going to keep the negative symbol. So it would be a negative 3. Let's do another example. We have negative 6 plus 4. Since we have an addition sign, we're following adding integers. That's our operation. It's addition. We have negative 6 and a positive 4. Those are different signs, negative and a positive. So we're going to subtract the numbers. So 6 minus 4 would be 2. And we're going to keep the sign of the larger absolute value. So negative 6 would give us a 6 when we take its absolute value. And a positive 4, when we take its absolute value, would give us a 4. This negative 6 gave the larger absolute value, so we would use the negative. So we have a negative 2 for our answer. While we're looking at addition, we might as well look at a couple more addition examples. Negative 4 plus negative 1. So it is an addition. So we go over here to adding integers. I have a negative 4 and a negative 1. They have the same sign, so we're going to add the numbers. 4 plus 1 would be 5. And we're going to keep the sign. Both of them were negative, so keeping the sign would make it a negative 5. Negative 3 plus negative 4. Once again, the operation is addition. We have a negative 3 and a negative 4. That means they have the same sign. So we're going to add the numbers and keep the sign. So 3 and 4 would give us 7. The sign for both of them is negative, so if we're keeping that, we have a negative 7 as an answer. Is everybody okay with adding integers? Let's look at a few cases where we get to subtract the integers, or where we change subtraction to addition. Let's start with 2 minus negative 4. Notice the actual operation symbol is subtract, so we're over here at subtraction. It wants us to leave the first term alone, so we're going to leave it as a 2. We're going to change from subtraction to addition, so instead of a subtract sign, we're going to put an addition sign. And then we're going to use the opposite of the second term. So the second term is negative 4. Its opposite would be positive 4. Now it's an addition problem, so we're going to go over here to addition. They have the same signs, so we're going to add the numbers and keep the sign. 2 plus 4 is 6. And then keeping the sign, this is positive, so this would be positive. Next one, 6 minus negative 2. So if I'm looking at this one, it is a subtraction problem. So I'm going to come up here to subtract. Wants us to leave the first term alone, so we're going to leave it at 6. We're going to change from subtraction to addition. And then we're going to use the opposite of the second term. So the second term is negative 2, so we're going to make it a positive 2. Now we follow our addition rules. We have 6 plus 2. So they have the same sign, positive 6 and a positive 2. So 6 plus 2 would give us 8 when we add the numbers. And when we keep the sign, we get a positive. So it would be a positive 8. For the next one, we have 4 minus 3. Now in this type of problem, you probably just go ahead and do straight subtraction because there's not really a lot of signs to get confused on. But if you wanted to follow the same rules as we were using above, we would leave the first term alone, change from subtraction to addition, and then use the opposite. Now since this is a subtract sign, then this is a positive 3, so we would make it a negative 3. Then when we were following our addition rules, they have different signs, so we would subtract the numbers and keep the sign of the larger absolute value. Absolute value of 4 is 4. Absolute value of negative 3 is 3. So this one's larger, so we would keep the sign of that one. So it would be a positive 1. Hopefully at this point you've written this down and can continually refer to it. I'm going to refer to it, but I'm not going to keep bringing the paper up to it. Alright, let's look at some more examples. 9 minus 6. If I was doing straight subtraction, 9 minus 6 would give me 3. If I was following my rules, like I've been practicing for integers, then I would leave the first term alone, change from subtraction to addition, and then I would use the opposite of 6. The opposite of 6 is negative 6. Then when I go follow my addition rules, they have different signs, so I'm going to subtract the number and keep the sign of the larger absolute value. Absolute value of 9 is 9. Absolute value of negative 6 is 6. So the 9 was the larger one, so we're going to keep its positive sign. So it would be a positive 3. Notice I get the same answer no matter which thought of reasoning I use. The next one. Negative 5 minus negative 2. Now this is probably more of the instance I would use my subtracting integer rules. This one was pretty self-explanatory, pretty straightforward with whole numbers. But here when we have the integers, it gets a little confusing as to whether we're supposed to add or subtract. So we're going to follow the rules. It says leave the first term alone, change from subtraction to addition, use the opposite of the second term. So the opposite of negative 2 would be positive 2. Now we have an addition problem. So we have a negative 5 and a positive 2. Those are different signs. So we're going to subtract the numbers. 5 minus 2 would give 3. And keep the sign of the larger absolute value. So absolute value of negative 5 would be 5. Absolute value of positive 2 would be 2. So this one's larger. So we would keep the negative sign. So our answer would be a negative 3. The next one. We have negative 6 minus negative 4. So this is a subtracting problem. So I'm going to go to the subtraction side. It says leave the first term alone. So we're going to leave it at negative 6. We're going to change from subtraction to addition. And we're going to use the opposite of the second number. The second number here is negative 4. So its opposite would be a positive 4. Now that we've rearranged the problem, we can follow our addition rules. So we look at the signs. This has a negative 6 and a positive 4. Those are different signs. So we're going to subtract the numbers. 6 minus 4 would give us 2. And keep the sign of the larger absolute value. So absolute value of negative 6 is positive 6. Absolute value of positive 4 is a positive 4. So this gives us the larger one, which means our sign should be negative. So our answer should be negative 2. A couple more examples. Negative 4 minus 1. So this is a subtraction problem. If I'm following my rules, I leave the first term alone, negative 4, change from subtraction to addition, and after this subtraction sign it was a positive 1, so its opposite would be negative 1. Okay, now that it's an addition problem, I see that they have the same signs, both of them are negative, so I'm going to add the numbers together and keep the sign. So they were both negative, so I should have a negative answer. Another example, negative 3 minus 4. Originally it is a subtraction problem, so we're going to leave the first term alone, change from subtraction to addition, and this is a positive 4, so its opposite would be negative 4. Now following our addition rules, they have the same sign, so we want to add the numbers. 3 plus 4 would give us 7, and we want to keep the sign, so it would be a negative 7. So if I wanted to summarize the same sign rules for addition, if I'm adding and they have the same sign, I want to add the numbers and keep the sign. If they have different signs, I want to subtract the numbers and keep the sign of the larger absolute value. If I am subtracting the two numbers, or subtracting the two integers, I'm going to change the problem to addition. By leaving the first term alone, changing from subtraction to addition. So I'm going to change the operation. And I'm going to use the opposite of the second term. If I was doing a summary at the bottom of Cornell Notes, this might be something that I was putting in there. I'd probably go through and explain how the addition worked and how the subtraction worked. Now, for just a minute, we're going to look at a few practice problems just to make sure that we have the idea. So if I'm looking at number 1, I have negative 4 plus 8. It's addition. Signs are different, so we're going to subtract the numbers and keep the sign of the larger absolute value. This would give a positive 4, this would give a positive 8. So we're keeping the positive 4. Number 2, negative 9 plus negative 7. This is an addition problem. They have the same signs, both of them are negative, so we're going to add the numbers and keep the sign. So I should get a negative 16. Number 3, 3 plus negative 10. So I'm looking at this one, it's an addition problem. They have different signs. This one's a positive, this one's a negative. So we're going to subtract the numbers. 10 minus 3 would give 7. And we'll keep the larger absolute value. So the absolute value of 3 is 3. Absolute value of negative 10 is positive 10. So we're going to keep the negative sign. So it should give us a negative 7. For problem 4, we have 0 minus 6. Now remember, 0 is not really positive or negative, But we all know if we start at 0 and we subtract 6 from it, we're going to have a negative number. So it makes sense to give us a negative 6. But if I'm trying to follow the rules, 0 would be left alone. Subtraction would change from subtract to addition. And then we would use the opposite of 6, which is negative 6. So if we're adding these together, we have a 6 because adding 0 to anything keeps it the same. And we would use our negative symbol because this one has no distance from 0. This is 6 away, so its symbol was negative, so we keep the negative. Negative 6. Number 5. We have negative 12 minus 13. It's a subtraction problem, so we want to change it to addition. Leave the first term alone, change from subtraction to addition, and the opposite of positive 13 would be negative 13. Now that it's an addition problem, they have the same signs, so we're going to add the numbers, and we'll keep the sign. Since they were both negative, we should have a negative answer. For number 6, we have 7 minus 25. Just thinking about that one before we start, if we have 7 and we're subtracting 25 from it, we're going to have to go into the negative number. So we're expecting a negative answer, just to check to make sure it's reasonable. If I'm following my rules, I would leave the first term alone, change from subtraction to addition, use the opposite of 25, which is negative 25. Now that I'm following my addition rules, I have different signs, so I'm going to subtract the numbers. So 25 minus 7 would be 18. And then I keep the sign of the larger absolute value. This would give me a 7, this would give me 25. So this one's larger, I'm going to keep the negative. So a negative 18. Number 7. We'll do one with several steps in it. Negative 8 minus 3 minus negative 10. And remember, these brackets are just another set of parentheses. They help us distinguish between sets of parentheses. So if we're following our order of operations, remember we're supposed to do everything in parentheses first. So in parentheses here I can't do anything. It's just negative 10. But in parentheses here I can simplify this part. So I'm looking at 3 minus negative 10. So I'll leave the first term alone, change from subtraction to addition, use the opposite of negative 10, which is positive 10. So 3 plus 10 would give me 13. So I have a negative 8 minus 13. Once again, I have a subtraction symbol, so I'm going to change to addition. Negative 8 stays the same. Then we change from subtraction to addition. The opposite of 13 would be negative 13. Since these have the same sign, I can add them together and keep the sign. So I should get a negative 21. Problem number 8. Negative 6 minus negative 10. If I'm looking at this one, it's a subtraction problem. So I'm going to leave the first term alone, negative 6, change from subtract to add, and the opposite of negative 10 would be positive 10. Now, following my addition rules, they have different signs, so I'm going to subtract the numbers. 10 minus 6 would give me a 4, and keep the sign of the larger one. The larger absolute value would be 6 and 10, so this one would be larger. Go with positive 4. Number 9. 11 minus negative 8 minus, in parentheses, 5 minus negative 4. Alright, lots of parentheses going on here. This one is just the parentheses to indicate that it's a negative number. Same thing in here, parentheses to indicate it's a negative number. In this set of parentheses, we actually have a problem, 5 minus negative 4. So if we're thinking about that part, we would change from subtract to add, leave the first number alone, and use the opposite of the negative 4, which is a positive 4. So 5 plus 4 would give us 9. So all of this simplifies to 9. So we have 11 minus negative 8 minus 9. So if we're working in order from left to right, we have 11 minus negative 8. So we're going to change this from a subtraction problem to an addition problem. We leave the first term alone, change from subtract to add, use the opposite of the second number, so negative 8 would change to a positive 8. And we'll just go ahead and write the minus 9 so we don't forget it. 11 plus 8, we're following our addition rules because we now have an addition symbol. Positive and a positive would still be a positive. They have the same sign, so it's a, since it's the same sign, they're both positive, it will still be a positive. We have 11 plus 8, which would be 19. And then we're going to subtract 9. And you could probably just do the subtraction. 19 minus 9 should give you 10. Or you can follow the subtraction rules. We would have the first number staying the same, change from subtraction to addition, make it a negative 9 because that's the opposite. They have different signs, so we would subtract the numbers, keep the sign of the larger absolute value. Larger one would be positive 19 instead of a positive 9, so we would have a positive 10 as an answer. Number 10. We have 9.5 plus 2.3 plus 8.7. Now this one looks a little different because it's not just positive or negative whole numbers. It is decimal numbers. But the same rules still apply because these integer rules apply to anything that is positive and negative. So all of these happen to be positive, which means we should be doing a lot of adding. So we have 9.5 plus 2.3. Remember, we line up the decimals. So 5 and 3 would give us 8. 9 and 2 would give us 11. And we just bring down that decimal. So these two added together, they had the same signs. So we added the numbers, kept the sign. Those were both positive, so this stays positive. Plus 8.7. Same thing. They're both positive, so they have same sign. So we're going to keep the positive sign. We want to come over here and add 11.8 plus 8.7, remembering to line up the decimal again. 7 and 8 gives us 15, carry our 1. 8 plus 2 would be 10, carry a 1. 1 plus 1 is 2. Bring down our decimal. So this would give us a 20.5. Since they had the same sign, we would keep the sign after we added the numbers. Next example, number 11. We have 3/4 plus 1/4 minus 5. Now once again, this is a little different because it's not just positive and negative whole numbers. This time we're looking at some fractions, but we still want to follow our integer rules. So these two are positive, so we want to add the numbers and keep the sign. So 3/4 plus 1/4 would give us 4/4, which is the same as writing the number 1. So we have 1 minus 5. Now we have a subtraction problem, so we're going to leave the first term alone, change from subtraction to addition, and use the opposite of 5, which is negative 5. If we're following our addition rules, we have different signs, so we're going to subtract the numbers, keep the sign of the larger absolute value. Problem number 12. We have negative 12 minus 34 plus 1 minus 8 plus 20. A lot of numbers here to deal with. Notice we don't have any parentheses, any exponents, or any multiplication or division, so we're just going to go in order from left to right on our add and subtract. Here we have subtraction problems. We're going to change it to addition. Negative 12 plus negative 34. Signs are the same, so we're going to add the numbers, keep the sign, so that becomes negative 46. That took care of all of that. We have plus 1, so they have different signs. We're going to subtract the numbers, keep the sign of the larger absolute value, so that took care of the plus 1. Now we're going to subtract 8. If we're following our rules, we leave the first one alone, change from subtraction to addition, and the opposite of 8 would be negative 8. Signs are the same, so we're going to add the numbers, keep the sign, so negative 53. And then of course we're going to add 20 at the end. Since it's addition, we look, they have different signs, so we're going to subtract the two numbers, and keep the sign of the larger absolute value. So negative 33 would be our answer. Number 13. We have 33 minus 24 in parentheses. Then we're going to subtract negative 8 plus 13, which is in a separate set of parentheses. Alright, we're supposed to do this stuff in parentheses first, so over here we have a subtraction problem. This is the same as 33 plus negative 24. They have different signs, so we're going to subtract the numbers, keep the sign of the larger absolute value, so that would be positive 9. Go ahead and put our subtraction sign. Over here in parentheses, we have an addition problem. They have different signs, so we're going to subtract the numbers, which would give us a 5. And the larger absolute value would be positive, so that would be a positive 5. So now we have 9 minus 5. It's just a straightforward subtraction problem. 9 minus 5 would be 4. Or if we were following our rules, we leave the first one alone, change from subtraction to addition, use the opposite of 5, which would be negative 5. They have different signs, so we would subtract the numbers, keep the sign of the larger absolute value, so positive 4. And we'll do one more, and we'll call it quits. So for number 14, we have negative absolute value, negative 7 minus 5, absolute value bar, minus 3, absolute value bar, minus 2, plus 1, absolute value bar. So these absolute values we would treat like parentheses, so we would do the stuff inside of them first. Same thing here, this set of absolute value bars, we would do the stuff inside of them first. So in here we have negative 7 minus 5. So that's the same as negative 7 plus negative 5. Signs are the same, so we would add those, keep the sign. So we're looking for the absolute value of negative 12, which would be 12. Now we have the minus sign out front, so that's a negative 12. Over here, inside the absolute value bars, we have negative 2 plus 1. Signs are different, so we're going to subtract. 2 minus 1 would be 1. Keep the sign of the larger absolute value, which would be negative. So the absolute value of negative 1 would be positive 1. And then out front of that, we have a negative 3 times that positive 1. So negative 3 times positive 1 would be negative 3. So we have negative 12 minus 3. First, we could change this to addition. So we have negative 12 plus negative 3. Signs are the same, so we would add the numbers and keep the sign, giving us a negative 15.